reversing malware in Mac. So she's from, I already told that she's one of the girls from Sans, and I hope you enjoy this. I know you will, but there she goes.
Thanks so much. All right, hopefully I will try to talk into the mic, but I will bounce around. So if you can't hear me, just, say mic or something like that. So a little quick introduction. Sarah Edwards. I don't speak Spanish at all, other than cerveza and baño, which I think is the two main ones I think I need to know.
Yeah, pretty much.
Yeah, I think I'm good.
Yeah.
So I'm a senior digital forensic analyst with a government contractor. I work in the Northern Virginia area, in DC, doing mostly computer intrusions, a little bit of malware analysis, counterterrorism, counterintelligence, secret squirrel gov stuff, right? So I'm fully embedded, full-time with federal law enforcement. I can't say which one. Figure it out. General forensics nerd. Definitely a Mac fangirl. Oh yeah. More than most people should ever like Macs. I'm also the author and instructor for the new SANS class. I got to pimp out SANS. SANS Forensic 518. It's all about Mac forensic analysis. We're just getting started with it in April. I'm super excited to be teaching it. If you'd like a class down here, I would love to come back during a really good weather time.
All right. We'll make it happen.
I'm still going by the pool we're at 10 o'clock, man. A little bit about the scope of the agenda for this presentation. This is not a hardcore reversing class. This is purely a basic Mac malware reverse engineering class. So we're going to do the basics. There is going to be no screenshots of assembly. I promise you this. Because nobody, I know, that'll be a whole other presentation. For somebody else to do, because I don't want to look at it, and I'm sure a lot of you do not want to look at it either. So it's about 20% static, 80% dynamic, and I got a little bit of the agenda right there. So get into the static analysis. This is working with the binary itself, with the application or the PKG file. What kind of information can we find out without running the actual executable? So I did a whole other presentation. When Macs get hacked, look it up, it's online, it's everywhere. If you can't find it, come to me. It's basically all about locating Mac malware. So doing an intrusion forensic analysis of a Mac intrusion. Yeah, I know Macs are not supposed to get hacked, but in fact they do. It's rare. But it does happen. I know, even at work, I work primarily Windows intrusions. For obvious reasons, they get hacked all the time. But I have gotten a couple Macs in, Macs, iPhones, things like that. So I'm really excited. I just don't want to get hacked myself. So what kind of malware files are we going to be looking at? The three that we're going to be looking at today are application bundles, PKG files, and Mako executables. But be aware that there's also, your normal Office documents, jar files, zip files, anything else you might see on a Windows box. So the application bundle. Who here knew, or well, kind of answer is up there now, who here knows that it's not just a singular file, it's actually a directory of files? Great. So we got some Mac fans?
Yes.
Who's a Mac fan? You're all my favorites. So the application bundle, if you look in terminal and do either a tree command or an ls-lar command, you can see that there's a whole tree structure. Up on the screenshots here, use my fancy green laser, we got one for the Safari app and one for Dashboard app. These are obviously not malicious or not malware, but these are what normal application might look like. Two required items. The info.plist contains a lot of configuration data, bundle name, things like that, and the executable. This might be located anywhere in there. If you do a file command, look for Mako executables to actually extract the executable from it. A couple other directories you might find are resources, code signing directories. You might see those if you download a Mac application from Mac App Store. All those are DRM'd with code signing. So I'll take an example here. We got Crisis. Crisis came out maybe 2 years ago, but it makes a really great example. You can tell on the right side here, this just looks bad. It just looks bad. It might as well just say evil.app, right? So up here we have the info and a plist, which I extracted out here, and using Xcode, you can actually view the plist, and it's in a human-readable format, because most of the time they're in binary format, and it's not very human-friendly. So here we have the executable file name, IZS or whatever, and most importantly, we have a bundle identifier, com.apple.mdworker. A lot of the things in Mac are named with a reverse DNS format, so com.apple, com.microsoft, com.google, so be aware of that. That basically just tells you, the company name and the maker of the software. Not saying that Apple actually made the software, but obviously it's not checked. So PKG files. A lot of these files, I'll be going into one called logtext. Has anybody used logtext before? Has anybody heard of logtext before? It makes a really great presentation example. You can download it off of Google Code. It's an open source keylogger. It runs on Mac wonderfully. But it makes a really good example. So a PKG file is an extensible archive. XAR, if you're really interested in it. It's one of the more obscure archive formats. Flashback used a PKG file, actually called Flash Player 11-macOS, shown in the screenshot there. And this is supposed to obviously look like it's a Flash Player update. Get the user to click me and do everything, and actually ask for credentials. User puts in their credentials, and boom, they are so pwned. So Flashback came out another couple of years ago, and this one made the national news. It made CNN. It was like 600,000 systems were infected, which is nothing compared to Windows malware. Nothing. But for Mac malware, holy crap. It was a game changer. So PKG files are kind of a pain in the butt to work with to try to extract the actual executable. There are multiple layers of archive you need to get through. So in the screenshot here, I have using the XAR tool, which is a native to Mac OS X, to list the contents of the package file. So we have distribution of resources, license, payload, scripts. So these are directories that you're going to want to look at. How do we get to those directories? So in the next slide, I'll get to that. But so unr, has anybody used the unarchiver? It's a really great Mac utility. Knows just about any archive you can even think of, even the most obscure ones. Great utility to have. The unarchiver. So UNAR is the command line version for this tool. So you can script it, and it makes it really easy to do some unarchiving without having to go through GUI. But comes with the tool, and I think it also comes separately if you don't want to have the GUI application as well. So to unarchive, we need to go through at least 2 steps. So the first step here, we can see that, okay, it has, doing a file, we can see a bomb, package info, payload, scripts directory. Now these are gzipped. So we have to use unr. I like that because it's one command, or you can use gunzip or whatever other utility you might want to use to extract the first time. So when you extract these, you get CPIO archives. So there's one more layer of archive to extract. Again, I use unr because one tool gets the job done, and extracted these. So you can see scripts-1 is the first layer, scripts-1-1, it's the default unarchiving system. So just another look at it. So first level is a gzip, second level CPIO. And this screenshot is just basically showing you what you saw before. The payload, the first payload is gzipped, second one is CPIO archive, and finally, we get down to a directory. Most importantly, this directory, the scripts, actually has the Mako executable that we're looking for. So Mako, this is the big, all the Macs use Mako. This is your PE executable of the Mac world. However, it doesn't look like a PE executable at all, not even close. So, Mach-O binaries, they may have one or more architectures associated with them. If they have two or more architectures, they're called fat binaries, which I find hilarious. And also, it gets even better with one of the tools that we use. So it can have, you know, a 32-bit executable and a 64-bit executable. It can have a PowerPC executable and a 64 and a 32-bit executable, all packed into the same executable format. And the system will determine which one to execute depending on what type of system you have. The example I have here is a 32-bit little endian. All of these are different file signatures. So if you're doing a file signature analysis, be sure to look more than for just Cafe Bay, which is kind of the well-known signature. There's also, 4 more to look for. So make sure you're looking for all of them. Example here, we have Cafe Bay, which is a universal / fat binary. You can see here, it has this is a crisis example, it has a 32 and 64-bit executable in there. So universal binary of two architectures, x86 and i386. And a Mac control. This one has a PowerPC component as well as a Intel 32-bit component. So multiple architectures, kind of neat. LiPo. This is how you interface with the fat binaries. Get it? LiPo. So it's an easy command to remember. So LiPo lets you review the architecture details, showing the screenshot. Mac control is used here, saying yes, okay, I have a PowerPC and an i386. i386 is 32-bit. FYI, it doesn't automatically think that you're doing a 32-bit i386, but it is. If we do a dash detailed info, you get a little bit more information about the CPU. CPU type, the offset in the binary, where the actual binary starts. So if there's 2 binaries, so first one starts at 4096, second one starts at 49152. So that might be good if you're, say, extracting it or you're looking at it in a hex editor and you want to see where it is at that offset. So we can actually extract the executables with LiPo. Dash extract, architecture type, and dash output for the output file. In the screenshot, I have the Mac control again, and I want to extract the 32-bit component of it. So I extracted that with LiPo, ran the file command just to make sure I have one executable with one architecture. So now I can throw that into IDA or Copper. Now, during this whole presentation, I'm going to be showing you command line stuff and GUI stuff. I try to have one of each for all the analysis items that I'm going to be looking at. Some people are more comfortable in a GUI, some people are more comfortable in the command line. So I try to give it out for both parties to have fun. So Mach-O View is a great application to view Mach-O executables. In the screenshot here, I have the Mach header. Has a lot of the same information that we just saw in LiPo. Architecture information, offsets, this one has flags and all the other static stuff you might want to know as a hardcore reverser. I frankly don't care. So strings, everybody loves strings. You know, I don't know any reverser that doesn't just run a quick strings on an executable once they get it, just to get the gist of what's going on here. So I have up here strings and search strings. Search strings is from the sleuth kit. Right? Sleuth kit?
The SIP, yeah.
Or is it?
It's just the SIP, yeah.
Yeah. So strings, the native strings on a Mac OS X system does not do Unicode strings. Be aware of that, because there might be some strings you're missing. That's why I gave the second option of search strings, because that'll also get all the Unicode strings, all the ASCII strings. And you should be good to go after that. Example of what you might find. A lot of, say, function names or variable names. This particular one, I believe, is from Crisis, and it checks for is lion, is leopard, set text path, kernel extension path, unload kex. So it's obviously doing something with a kernel extension. Good things to know and good things to look for. Now, in the Mach-O view, I found the exact same strings, as best as I could, in Mach-O that I found with just the strings utility. So again, we have the isLion, isLeopard, all the kext stuff, load kext, unload kext, same thing, but it's in a GUI version. So symbol table. Symbol table is good so you can view variable and function names. OS X has a native tool called NM. And when I say native, in most cases you're going to want to have to install Xcode to get a lot of the programmatic utilities like LiPo, like NM, and stuff like that. But I imagine if you're doing this anyway, you probably already have Xcode installed. So again, this is the crisis example. And a simple command, NM, the executable name, I'm not even going to try to pronounce that. You get a whole lot of symbols here. Now, like there's symbol names, function names. Again, you get the gist of what might be happening with this binary. Now the Mach-O, back to the GUI. Same thing here. They have a whole section just for symbol table and symbols. It's nice, it gives you the offset, it gives you other information, but this one is a little bit more verbose than NM is, but same general information. Which brings me to the hopper. Thank you. So we were discussing earlier whether you guys had that commercial down here with the hopper. Yeah. Apparently you do. Because I was going to make a joke. I'm like, oh, what if they don't have the commercial? I'm going to look like an idiot. But yes, every time I think the hopper, I can't help but try to say it with a Boston accent. That commercial has ruined me. So, I mean, this is just a screenshot. It's obviously very difficult to see because it's dark and it's a giant screenshot. These slides will be available. I should have mentioned that earlier before you all started taking notes. My bad. But I will make these available to you. At some point, I will put up with a bit.ly link or something on Twitter or something. Just if you can't find me, I am Evil Twin, EVL Twin on Twitter. I'll get it to you, or come up to me afterwards.
We'll post it on the B-Sides webpage if you.
Okay, great. It will be available to you. I always give my presentations out because they're always really long. And it's always just pictures. So Hopper app, anybody who's used IDA can probably just go right in there and fool around with it and get used to it. I mean, IDA is how much now? 1,500? I don't know. Is anybody actually?
17.
Yeah.
17.
This one is, what is it, 80 bucks now? 70 bucks?
Did it go up? Because it was like 60.
It went up with version 3. So, yeah. The guy actually, I guess, quit his job and now is doing this full time. So, dude needs to make some money. So, go ahead and buy this because as far as reverse engineering software goes, this is cheap and it's good stuff. So, if you're a static person, I didn't say there was actually screenshots of assembly, aren't there? I lied. One screenshot, and I'm not even going over it, just purely example. What's that?
They need to learn that universities are not teaching it here. I already know this.
All right. One thing with Mac that we don't often see with a lot of Windows executables is code-signed binaries. So anything off the App Store and like developer stuff, you can sign your binaries. This became an issue with a popular malware called Kumar in the Mac, or KITM. This was actually signed by a developer, which means, and I'll get into this a little bit later, it was able to bypass Gatekeeper, which is one of the AE products, to use the term loosely, on Mac. So this was a big deal. Now like people are like, oh shit, even if it's signed, it can still run. So use the command, check the code signatures, and we got Kumar here just hanging out. It actually took them Apple took them quite a long time to revoke the certificate, but there are other ones out there, so be aware. It's not just Kumar doing this, it's other folks too. Not that I personally know any of them. So some dynamic analysis. Now we're getting into where we're throwing it up in a VM, executing it, fooling around with it to see what it does. Virtualization. So VMs for Mac, relatively a new thing. Apple did not want to do this. Like as of 10.6 server, you can virtualize that. But 10.6 not server, you can't do it. But everything 10.7 and above, you can virtualize in VMware Fusion, Parallels. I think there's probably some other programs out there. I don't know if you can do it VirtualBox. Anybody have any?
I have done it.
You have done it? Is it a hack or is it native?
As long as it is on Apple hardware, they'll let you
Right.
do it.
Yeah. It has to be on Apple hardware or technically you violate the EULA.
Even on VMware ESXi, but
Right.
you also need Apple hardware to
Right.
do it.
But I hear VMware ESXi runs really well on a Mac Mini.
Yes.
Yeah. So, you know, options. You got options now. It's something that you didn't have. You know, what, 10.7 came out 2-3 years ago, give or take. And this is relatively new. It works great for research, too. I have so many Mac VMs, it's ridiculous. So we have XProtect. XProtect is a signature-based antivirus product built into OS X. This is Apple's AV. A couple of the files that you might want to look at, system library, core services, blah, blah, blah. There'll be xprotect.meta.plist, when it was last updated, what version is it, and a couple of blacklisted plugins. So all those Java plugins that Apple's like, oh, no, 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 you cannot run that. That is bad, I know it's bad. So a lot of Java, a lot of Flash. Just try not to install those in your system anyway. But we know we all do it anyway, right? The other one is a xprotect.plist file. This one will contain all your signatures. Last time I checked, I feel like it was 30-some items with maybe multiple signatures underneath that. So as far as it compares to a professional AV product or a free AV product, a third party, they're very small, limited signatures. So these are part of the weaknesses with XProtect. Apple updates it on their own terms, and they update it silently. You don't know what's happening unless you're capturing, you know, PCAPs or something like that. There's very few signatures, no heuristics, nothing. And it only checks quarantine files. So that's the key. Question? Oh. So it only checks quarantine files. So in the screenshot down here, if you've ever looked in a terminal before, and some people who are new to Mac might not know this, the little @ symbol, when you do a long listing in terminal, that means you have extended attributes. Mac loves attributes. There's so much metadata. I mean, there's dates, there's like so much forensic goodness. I try not to make this a forensic talk, but they're so good. You can totally nail people with their metadata. They do not know it's there. So one of the examples here is the comp.apple.quarantine. When you launch an executable and it has this extended attribute attached to it, it will, you know, run it through XProtect, run it through their signatures, see if it matches any of their signatures. And sometimes it'll hit. And next slide, I'll show you what will pop up. So comp.apple quarantine quickly just tells you, you know, where it was downloaded from, when it was downloaded, like, yeah, just where and when, and some other identifying information with it. So in here, this is the xprotect.plist file. This is an example of a coin thief. That one just came out just a few months ago. That was the Bitcoin miner. So it steals your wallet, it steals all that good stuff. I really wanted to try to find a sample of that. So if you have one, let me know. I'd be appreciative. So this one, if you take out the identities here, so this data here, that is just a SHA-1 hash of the files that it's looking for. So no heuristics, it's only looking for a hash. So if this executable matches that hash, it won't execute it. Oh, you're good to go. If it, you know, you can change a hash quite easily. So it does not help you protect that well. So a little bit about, you know, what other kind of things. It also looks for things that get executed along with it. So this one is an example of mdropper. It's looking for a, you know, when you launch Microsoft Word. And then if you extract this pattern here, which is the data down here, it's also looking for script contents. So temp launch, bin shell, and file.doc. Because what it does is it opens up a document or it looks like it's opening up a document and opens up a decoy document. Meanwhile, it's pointing you in the background. So XProtect, why you should disable it in your VMs, and only do it on your VMs. So don't do this on your real box. You know, it is crappy, but you probably should have it running. I don't even know if Apple had issues. I'm sure it'll probably just say no, you can't delete this, or it'll restart or something. I'm sure that's like something that Apple would do. So a couple of things you could do here. This is the box that you might get. I tried to open this codec M installer. It's a random piece of malware. I'm not even entirely sure what it does. But this is the disk that you get, or this is the picture that you get. It says, no, I'm bad. Don't open me. Okay, great. How can I run this thing? All right, delete the XProtect files. Delete or edit. You can remove all the contents of it. If it's a VM, if it's an offline VM, it shouldn't be updating anyway. So hopefully it should not have any issues. Or you can just kill off the com.apple.quarantine extended attribute. XATTR is a native tool. Basically, it's interfaces with extended attributes. You can print them, you can delete them, you can create them. Pretty nice utility. So -D will delete the quarantine, and you should be good to go. So Gatekeeper, along the same lines, is that anti-malware feature. This came around in about 10.7.5, and it restricts the execution of certain programs. So you get three options, and in the screenshot here, this is what you see in the security and privacy preferences panel. You get three options. Mac App Store, run only things from the Mac App Store. Second option, Mac App Store or identified developers. Remember the kit M? It's still going to run this way. This is the default as of 10.8, so you're still going to get owned by the kit M Kumar malware. And anywhere, which I of course have selected because I live on the wild side. Thank you. Yeah, go ahead, own me. See what happens. So anywhere means you can run anything from anywhere. It doesn't matter what. Apple's not going to complain about it. So be sure to set that setting so you can actually run some of this malware. Otherwise, you'd be like, damn it. And you'll be getting this screenshot here. Tried to install some weird call and record demo, some crazy thing that I downloaded from SoftKey. There's so much malware on SoftKey. You just go to it and download some advanced malware. So to disable this, go to allow application download from, click anywhere, or on a case-by-case basis, you can control-click and execute the application. Click OK, yes, execute. Application tracing. I have a slide on this because it's pretty much the basis of all the analysis tools. Has anybody ever heard of Dtrace? Okay, those are the real nerds in the room, that's for sure. So application tracing. This is a low-level logging. It's incredibly verbose, has a lot of information a lot of people may not understand. I'll try to simplify a lot of it for you. Usually meant for debugging and program folks, but it's super useful for reverse engineering as well. A couple of the software things that use it, definitely Dtrace, fs_usage, which is a default native program, and the Xcode Instruments application. So Dtrace is great. So this came around 10.5. It's built in. It's designed by Sun Microsystems. There's a whole book on it. I highly recommend. I mean, this book's like this thick, give or take. It's a hefty book. If you want to know anything about Dtrace, go to dtracebook.com or go ahead and get the book. It'll be very worthwhile for you. I've been making my way through it, and I'm just like, wow, there's tons of information here. And they have code samples, and you can download the code samples on the website here. But this lets you interface with a lot of the low-level network file system, CPU, memory items. So even if you're doing research, completely not reverse engineering, more system research, this isn't something that you really want to learn. It's very awk-like, so anybody who does some old-school awk stuff, for one, love awk, and I still use it almost every day. I'm a nerd. Yeah. set and awk. I think you'll be able to program it in quite easily. One of the examples here, this is an easy one-liner. We'll go into this a little bit more in depth later on. But this is files opened by process. You execute malware, you want to see what processes are opening and what files they're opening, right? So quick little things, just call open, and it prints the screenshot there. So we have CPU, probe ID, the function that it's probing or looking for, the application, so Google Chrome, and the file that it's opening. Xcode Instruments, this is the GUI version, and I'll use the term version loosely because it has as much functionality as Dtrace, but Dtrace is a small part of Instruments. It's a graphical version of it, but it has a lot more functionality built into it. You can look at this and play around with it for hours. It's really neat. Most people don't know it's there. It's installed with Xcode. I think you actually now have to install it separately. It's called Xcode. What's it called? Xcode Tools.
Yeah, the command line.
Yeah, command line. Thank you. But you can get to it through, going up to Xcode, Open Developer Tool, Instruments. This is a little screenshot of what it looks like. So it shows you a graphical version of, how many files. It shows you peaks and valleys, timestamps, calls, things like that. Quite useful. You can even write Dtrace scripts within Xcode to execute in Xcode. So if you want a pretty shiny version of it without the terminal output, it's very useful to use. So a little bit about file analysis. We're going over some Dtrace, some FS usage, and fseventer. Dtrace script, file by proc. This one opens up, it's files opened by process. We really want to look at what kind of files is this thing opening, is it creating, is it touching, is it working with. And again, this is very similar to what we saw before. You see the application name, so we got Finder, Doc, Touch, and the path. So in this example, you can see I touched a document called test.txt. Things like that, just the configuration, all the MD worker and VS, that's all related to the metadata service for Spotlight. So in a normal working system, you will see overpopulation from MD worker and Spotlight stuff. There are some of the tools will actually be able to filter out a lot of this, but you can also filter it out on the back end using grep or what have you. Another one, files open, gives you a slightly different view on things. So this one actually opens and shows you the process IDs and the UID that opened the process or started the process. Could be quite interesting. Shown here, you see 501, a normal user. We also see the root user also doing some stuff here with text edit. So good information to know which user, is it an admin user, is it a regular user, doing some stuff. And again, another one, there's a lot of Dtrace scripts and they all are a little bit different here and there. You just got to figure out which one you like best. Open Snoop. So open Snoop-A equals all data. Like, just give it to me, let me filter it out myself. So open Snoop gives you a couple of timestamps. The first one is a relative timestamp. Second one is actually the system time, I believe, and local system time, or maybe UTC. I'd have to look that up. I can't remember. And still has the UID, PID, process, and file. So that one gives you a ton of different information. So we also want to see files read and written by the process. It's a little bit different. This one shows you the block sizes, where it is in the file system. So if you really want to go find where that file is written to, you may do so. Example shown here. Now these examples are normal system usage. I'm not running any malware here. This is normal. So we have launch D doing something with ASL files. That's Apple's system log. It's very syslog-like. It's Apple's version of syslog, pretty much. Interesting log stuff. So files opened by process. Again, this one's create by proc.d. Some of the same information. And kind of see, it does Google Chrome, cat, sh, cat, trough, a ton of different things, right? It's all about finding what you know, what you like. I mean, a lot of these can be easily scripted out too. However, some of them do not like to be played around together, and they fight. So, Dtrace will be like, no, you're already doing something with that. You can't be doing something with this. So you might have to run the malware over and over again, using different tools if that's what you want. Another native tool, fseventer. This one's hugely verbose. I have up here two arguments. -w is for wide, meaning you get a wider view and get more information out of it. And -f is for filter. So this one has a bunch of different filters in it for different types of things. We're going to go over the path file, or excuse me, path name, exec, disk IO, filters. Sorry, did I just like blind you with the laser? I keep hitting that accidentally. So -f path name, we're using the path name filter. This will get us a timestamp, the calls, file path, time interval, and process name. Some calls of interest. I recommend going to Apple Developer documents, looking up these calls. You can even do like man get attribute list. It'll show you a lot of information about that particular call. A lot of the documentation is built in. So, like Windows stuff, you might be going on MSDN or Google searching. A lot of it's built into the OS. It's really nice. So an example of the path name, I had to, because it's so verbose, I had to take it out of a screenshot and actually put it in as text, because it's seriously like this long. You have to to make it look pretty in a terminal, you have to make the text size this big. Highly recommend putting it output to a file. So this is an example of, get attribute list. It's doing something with the messages application with the doc. What I did there was I clicked on messages and opened it up. So we can see some interfacing with Google Chrome here. I was, of course, browsing the web, things like that. Disk IO, a lot of the similar stuff. We got disk block byte count again, similar to what we saw before with file path and processes. A couple examples here. You see my Gmail. Feel free to email me. Not my primary account. Probably won't answer you. Oompa@csh. Then we also have here some Google Chrome, doing some local storage. I was rocking out some tunes on RDO. You can see a lot of this stuff is normal. So if you're working with a lot of this stuff, you have to know what is normal and what is not. Look at your activity while you're just browsing the web and doing normal email and things like that. Because I'm not kidding when I say verbose. You like Procmon. Who uses Procmon? Yeah, it's similar to that. It's a ton of information. If you do like FS usage with no filters, it's very similar to Procmon. It gets the network, disks, processes, all sorts of information. So the GUI tool for all this, fseventer, by the folks at Fern Lightning. It's a GUI application. Has a couple of different views that we'll see later on. Also able to filter, using a text input filter, do live filtering and stuff like that. And it does have the ability to save it to an output file. So this is, I don't care for this version viewer mostly, but it does show you the various what's it called, levels of the file system. So you have the cliff stall users, library, sync preferences, getting hit with some plist files. So it does help you visually see where files are being written to at what time. Of course, my preferred one, very Procmon-y, is the table view. Just sort by time and let me look at it like this, So it has file path, time, what type of action event occurred, and the process that it occurred with. This one shows you the filtering, so I filtered here by plist. I want to know what plist files are being written to. Those not Mac users, plists are like the registry of the Mac world. Instead of a few hives, like 5 or 6 hives that Mac or Windows has, there are hundreds and hundreds of plist files. So each application, each thing has a separate plist file. So process analysis, another couple of Dtrace scripts, some FS usage again, and some more GUI applications. So we want to snoop new processes. We want to see what's being executed, what's spawning new processes. Newproc.d shows us if it's a process, what the parent process is, timestamp, whether it's a 32-bit or a 64-bit executable, and command line arguments and things like that. So a couple of examples here I'll point out. This here is when I double-click the Notes application in Mac. It has a bunch of different things listed with it. It's got framework stuff, XPC stuff, it's all services and things like that. I did a man if config, quick and easy, simple, and I did an open-a text wrangler. And I opened the text wrangler from the command line. So interesting information there. Again, new processes, we use exec snoop. This is one of my favorites. It does the relative time, it does the current time, UID, PID, parent ID, and arguments. Pretty darn concise too, which is why I like it. You easily see on the command line what's getting run at that time. And it's not too verbose. Again, FS usage with the -f exec filter to it. A lot of the same information, time interval, processing, path. We're looking for, POSIX spawn. That's a spawn process. Exec VE is a new process. We see bin sh, man, table, graph. These are all command line tools that we might be interested in. Malware might be using some different ones. That's basically me doing a man page lookup, right? Real-time process looking. We use this Process Explorer on a Mac or a Windows system. This is basically a terminal version, Mac version of Process Explorer. Yeah, it's like top with a few more functionalities and coloring, and it's all sorts of, pretty and whatnot. Now these screenshots suck. I know. But you can't make terminal stuff look good. It's just impossible. So we have, a bunch of different columns here. Process ID, it's interactive, so you can click down and press enter, and more information will pop up about that process. That's shown in the lower screenshot. I can see it's 64-bit. I can see the size of virtual memory it's using, what other processes is running underneath it, things like that. And of course, we have activity analysis, or activity monitor, excuse me. This is obviously native. Whenever Spotlight is taking up a lot of RAM on your computer, which happens a lot, why is my computer so hot? Why is the fan running so hard? This is what you're going to open up and kill the process, right? It's very much like on the Windows side with it. Thank you. I forget how to use Windows sometimes. So, pretty much the same thing. What? Are you making fun of me?
You're not the only one. There's a lot of people in Windows.
I forget the names. I'm like, yeah, that thing. So network analysis. I don't like Windows machines. I really don't. Network analysis. Wireshark is always popular in the Windows world. Cocoa Packet Analyzer. Let's get into it. So Cocoa Packet Analyzer is it's a native tool. Not native, excuse me. It's Mac-only tool. It only runs on a Mac. It's very similar to Wireshark. It is kind of finicky because it sort of caches packets, and then it shows it to you in like sets of 10, or however much you have it set up. So it's not completely live, which bugs the hell out of me. But it is really nice. You don't have to install exports or whatever. I mean, it's pretty slick. When it comes down to it, it's pretty damn slick. Wireshark, the all-time favorite. I had a hell of a time when I was doing running this stuff in a VM. So I usually have a clean VM and a dirty VM when I'm doing analysis, network together, for whatever reason I need to do. Wireshark will not freaking install on 10.7 or 10.8 systems in a VM. It shows up blank, and I'm like, are you kidding me? I'm like, what am I doing wrong? Now I know like Mac VMs can be a little bit buggy, especially when it comes to video stuff. If you ever open up Safari or open up, what's it called, iWork stuff, you'll have a full page of text, but it'll show up blank. So it has some issues with video, so be aware of that. But Wireshark, I'm like, damn it, I'm gonna get this to work. It works in a 10.9 VM. So FYI, it's not you, it's them. It's not so much. Why can't it be native already? I don't understand.
They're working on it, but you can go into the beta.
Is there a beta?
Yeah, but it's not,
Not stable? Okay, good to know.
That's what he said, it's still working.
Yeah. So command line version, got to give you two options. We got good old TCP dump. I give you a couple options here. One with content, one without content. I like to see, I like to see the content of the packets when it's rolling through, seeing, if it's making beacons to certain things. I want to see that live, right? So I personally like the with content. In network analysis, you can also do this with Activity Monitor. You can see which applications are, using more network, push and bytes to, which application is using most network throughput. And one more, this is like a TCP view type thing. It's called LSOC. These are all written in, LSOC and Process XP were all written by, and I forget the dude's name, the guy who did the new OSX internals book, Levin, something like that. Look it up, it's a great book. Amit Singh had the old, OSX internals book. Kind of had to be updated. I think it was last updated 10.4. Been some time, but now it's updated. I highly recommend it. Has all sorts of good internal stuff. I read it at night, page by page. Yeah. So, obviously screenshot sucks again. But it does a colorized view. It's very much like TCP view.